offshore renewable energy catapult. For those of you who don't know about the catapult network, just over 10 years ago, UK government set up a network of catapults. Offshore renewable energy catapult is my one. I've seen some people from high value manufacturing and energy systems here today. But essentially we're not for profits to sit between government and industry to drive innovation. Historically, my organisation has focused on that innovation bringing down the cost of energy in the offshore wind farms, so that's been very successful. Now it's got to the point that offshore wind is now a mature technology. We're looking to other areas where industry is leading, and offshore wind looks like it wants to lead in the maritime decarbonisation space. So my role is looking at clean maritime operations in offshore wind. Specifically, I'm based out of Grimsby, the world's largest offshore wind port in terms of the amount of capacity it services there, and we're based there to try and enable the industry to decarbonise.
My name is Untitled Chapter. I'm a researcher at Cranfield University, Department of Thermal and Power Engineering. I'm working under a project with Professor Reeves and Dr. Sanders to design a liquefied hydrogen tanker ship with a total capacity of 280,000 cubic meters, powered by hydrogen. The propulsion system is a combined cycle gas turbine to achieve the zero emission maritime target for the UK and for the climate mitigation targets.
Thank you. And once again, thank you very much for stepping in at the last minute. Very much appreciated. Okay. Dinesh, you started on something. First of all, it's great to see how many different technologies and options were being explored as part of the Clean Maritime demonstration project. Very different to possibly something that was being shown in the aviation sector earlier. It seems to be pointing towards one option. But can you tell us, does ammonia have a role to play in the future for maritime decarbonisation?
Yes, I think if you look at the latest development from the marine propulsion industry, so they already have the engines ready, internal combustion engines ready for ammonia. So if you look at some of the very latest development from Man Diesel and Wärtsilä, and so these are the main shipping engine manufacturers. So they have the prototype engines ready for ammonia, two-stroke and four-stroke. And also I think the other gas turbine manufacturers like Siemens, they probably have the gas turbines ready for ammonia as well. But there are a lot more research going on in terms of the fundamental level research at the various universities to utilize ammonia as a fuel in internal combustion engines and gas turbines, and also possibly in fuel cells as well, relevant to the maritime decarbonization.
Is ammonia anything you've been looking at within the ORE?
Yeah, certainly. As an organisation, I guess we try and be, to a degree, fuel agnostic. I'd probably say e-fuel agnostic, for reasons that were pointed out in a previous one of these forums. The things like HVO, so your biofuel of the maritime sector, aren't particularly appealing, specifically within offshore wind, who wishes to drive the sector not just utilising vessels that are clean, but also potentially supplying the fuel for that. So along that line, you've got hydrogen, electric battery, ammonia, methanol. Within that, I guess what I would say in terms of will ammonia play a part is we're still very early on in the maritime sector. When we look at automotive, people are talking about how many tens of thousands of miles and how many hundreds of trucks they were doing. If you look at how many, not just in the water at the moment, clean zero emission vessels, but also how many on order at the moment, it's a tiny amount. So we need to get these vessels in the water to demonstrate whether things like ammonia will play a large part.
That's a good point. In terms of what do we see there as the main challenges relating to maritime decarbonisation? You say you are a bit further behind that pathway. what are those challenges and how we overcome them?
The main challenges for the maritime decarbonization, the storage of the hydrogen on board of the ship. By comparing hydrogen with liquefied natural gas carrier ships, as already we did a design for a large scale hydrogen tanker ship. With comparing the two designs, hydrogen could be carrying 20,000 tons with the same size of the liquefied natural gas, which is carrying 120,000 tons. That means the size of the ship needs to be very large compared with the weight, and this is affect the ship stability because the draft will be very low, and the hydrogen carrier ships, liquefied hydrogen carrier ships, will be unusual design. We can compare those ships with cruise ships because it's carrying people with lightweight, and with aircraft carrier. By comparing the draft, that will be very low draft, and this thing will lead us to use or to avoid the draft of the ship. Lead us to use the Azimuthal Propulsion system, which is a turboelectric system with a combined cycle. The combined cycle will be prime mover for the electric tanker, and the Azimuthal will be as a propulsion system, propulsion system. The selecting of combined cycle, because it's compact in the size and can achieve 55% of thermal efficiency, which is compared with the diesel engine or the current diesel engine. At the same time, economically will be saving in the fuel because waste heat recovery technology. Moreover, environmentally, we can achieve low NOx emission because also we have waste heat recovery technology. By comparing the tank design, that's like this ship, we can have 1,000 ton, 1,300 ton tank to carrying the hydrogen, which is fueling the ship. At the end, by comparing the electric tanker and LNG tanker, there's a big difference in the design to achieve the optimum fuel saving and emission target.
Can I add? So in terms of the key challenges, you can look into three main directions. So the first one is the vessel design itself, and then the second one is the operational aspects, and then the third one is using alternative green fuels for the propulsion. So these are the three different directions you need to look broadly if you want to achieve 100% decarbonization from the maritime sector.
I can never match the sort of the technical expertise we have on that one there. Yeah. But what I would say is that I think the challenges that you said, particularly because we've got people like you, they're achievable. We can get through them. The big roadblock at the moment is money. When you actually talk to people behind it, when we look at road transport, certainly recently, all of my friends that have got EVs, they're seeing a huge benefit because the government was able to stick a big tax onto your fuel. Because it's all domestic, electricity is a much cheaper option for them. When you look in maritime, and to agree aviation as well, I guess, you stick a big tax on UK marine bunkers and people fill there is no real financial push for someone to use hydrogen over MGO. In an ideal world, IMO would come down and say, okay, we're going to stick a flat tax across all. That's probably not going to happen anytime soon, so we've got to try and look and be inventive to say where we're going to get that financial push from. Emissions trading scheme, UK government is currently consulting on, and I know there's similar things in the EU, but it may need to be more on a sector by sector basis. A vessel operator looking to decarbonise their fleet may be paying up to 4 times as much for the potential decarbonised fuel. But actually, if they're shipping trainers across the world, I think the guy from Maersk gave an example, that cost is actually only 50 pence more than a pack of trainers. If you can stick a big green label on there and get some commercial benefit, people are going to buy into that because it's only a small amount of the end product. It's one of the reasons I think in offshore wind it's achievable, because actually we give these offshore wind sites consenting from Crown Estate, and then they go into a consenting round for a CFD in offshore wind. Just tell the operators at that point you're only eligible to bid in if you've got a clear maritime strategy. Suddenly creates a level playing field. It means if you're green, you are not financially imposed. It's not going to make you worse off. So I'd say the big one at the moment is money, and once the money's in place, suddenly these technical challenges